Welcome back to this next video in which we are discussing Acne Vulgaris. Okay, so we're currently in the process of discussing the sebaceous glands, and what we have said so far is that the sebaceous glands secrete an oily substance known as sebum, and that sebum acts as the skin's natural moisturizer. We've also said that sebaceous glands come off hair follicles, and that hair follicles are found distributed over nearly all of the skin that covers the body. In fact, there is a special name for areas of skin that do not have hair follicles and therefore also do not have sebaceous glands, and these areas are known as glabrous skin areas. And the only two major examples of the human body that are covered by glabrous skin are the palms of the hands and the soles of the feet. All of the other areas of skin are so-called non-glabrous skin, and they do have hair follicles and therefore do have sebaceous glands. And I stressed to you in the previous video that some of these non-glabrous areas you don't think of as typically having hair because you can't actually see the hairs because they're so tiny. Whilst other areas, such as the arms and the legs, they may have large enough hairs that you can actually see them. Okay, so important learning point from the previous video is that most of your skin is non-glabrous and does have hair follicles and does have hairs and does have sebaceous glands, even if these hairs are maybe tiny in some of these areas and not visible to the naked eye. So, the next thing that I want to talk about is I want to take this picture that we've drawn of the skin here and I want to extend it so that we have a hair follicle also on this picture so that we can have a look at the structure of hair follicles, and I also want to show you a sebaceous gland coming off that hair follicle. So let's begin this. So I'm just going to extend this picture. So here is some more epidermis here, and then we'll have the dermis underneath. Excellent. So what I want to now stick in the middle there is a hair follicle. Now, what is the structure then of hair follicles? So hair follicles are effectively invaginations of the epidermis downwards into the dermis so that they form a pit, and in that pit is where the hair is going to sit and stand up. So let me show you this on this picture. So here we go. Here is the epidermis invaginating inwards like so, and I'll also make sure that the lower boundary of the epidermis also invaginates inwards like so. So this is the hair follicle, and as we've just discussed, these are distributed over all of the non-glabrous areas of skin. Another thing that I'd just like to point out is that when people talk about their pores, the pores on their skin, what they are referring to is the visible entrances to the hair follicles that you can, if you look carefully, see on your own skin. So if you look at a non-glabrous area of skin and you look very carefully, if you've got good eyesight, you can do it with just your eyes. If you haven't got so good eyesight, then get a magnifying glass. You can see your entrances, your little hair follicles. You can see the entrances to your hair follicles on non-glabrous areas of skin, and people refer to those little holes as their pores. So that's another piece of terminology that you may have come across. So let's next add on to our picture here an actual hair. Now ideally, of course, I would draw the hair in black or brown, but that's not going to show up, so instead I'm going to choose the colour green to draw the hair in here, just because it shows up. So there, that is going to represent our hair. Now you can see that my picture is a little bit constrained by the fact that we have this image above, and hence I have drawn a tiny little hair here. This would be one of these microscopic hairs that you cannot actually see with your normal eyesight. If I wanted to draw a hair that is large and macroscopic, such as a hair, for instance, on the arm, I would draw a much larger hair. So this is a small hair that would be microscopic and would not be visible to the naked eye. Okay, so there we have a hair sat in a hair follicle in a portion of non-glabrous skin. The next thing that I want to show is a sebaceous gland coming off the side of that hair follicle. So just as the hair follicle was effectively an invagination of the epidermis down into the dermis, a sebaceous gland is going to be an invagination again into the dermis, but this time it's going to come off the side of the hair follicle. So I'm going to draw this in yellow, and this is the point where the picture is going to get a little bit, how should I say it, a little bit tatty. Okay, it's going to look a little bit more messy, but hopefully you'll get the point. So here we go. Here is a little sebaceous gland shown here in yellow coming off the side of the hair follicle, and I just now need to rub a few little bits out. So I'll rub that bit out, rub that bit out. And it's not going to be perfect, but I hope that you get the message. So it is an invagination off the side of the hair follicle going into the dermis, and the lumen of the sebaceous gland here is continuous with the lumen of the hair follicle in which the hair is actually sat here. So this is the glandular epithelium here that is actually going to secrete the sebum, and I might use the white pen here and just draw a bit of sebum in the lumen here. So this white stuff, this is representing the sebum, this oily substance that is the skin's natural lubricant. And you can see that it's going to go into the hair follicle, and then it's going to go up the hair follicle and onto the surface of the epidermis to act as a lubricant. Now, in my picture, I've just drawn one sebaceous gland coming off the side of this hair follicle. In reality, most hair follicles have a huge number of sebaceous glands coming off. So if you want, you can imagine that there's another one coming off here, another one coming off here, another one maybe coming off here. So lots and lots of sebaceous glands all secreting their sebum into the same hair follicle. And we have loads of these hair follicles dotted around on non-glabrous skin areas. There we are, we have completed the necessary anatomy and physiology to understand the pathogenesis of acne. So let's now begin the story of the pathogenesis of acne. So, a few little facts firstly. Acne is a very common skin disorder, and it primarily affects people in their teenage years, so-called teenage acne. And it's extremely common. In fact, it affects about 85% of teenagers. It is very uncommon for it to affect prepubescent children, and if you do have, let's say, a 5-year-old with acne, then you should consider whether there is some sort of endocrine problem occurring in that child that is causing the acne, because acne should not occur in a prepubescent child. It's so common in the teenage years that it's not actually completely considered a disease, it's more considered actually almost physiological. However, whilst in many people it gets better after the teenage years and goes away and the adult life is free of acne, in some adults, particularly in women, but it can also occur in men, it carries on past the teenage years and can even continue on to the age of 40 and beyond, and that's called adult acne. It is very rare for someone who did not get teenage acne to later on develop adult acne. Nearly all cases of adult acne began as teenage acne. So they had acne as a teenager and it just never went away, rather than not having acne as a teenager and then developing it in adulthood. So to summarize what I've said there, it's a common skin disease in teenagers, it shouldn't affect prepubescent children, and it usually resolves after the teenage years and is gone by the time you're an adult. However, it can continue into the adult years, and then it's called adult acne. So, let's now consider the pathogenesis. We will discuss the pathogenesis, and then later on we'll come back and try and answer the question of why in the teenage years does it start? What actually happens that causes the acne? So, let's then start the pathogenesis. So the fundamental thing that goes wrong in the skin that causes acne is a phenomenon called hyperkeratinization. And this is a big word, so I'll write it down for you. So this is the fundamental problem that causes acne, hyperkeratinization. And this starts being a problem usually in the teenage years. And the main reason that hyperkeratinization starts happening is believed to be hormones, in particular the male sex hormones, androgens. But of course, even though we call them the male sex hormones, they are also present in smaller amounts in girls as well as boys. So, what does this massive word then actually mean, hyperkeratinization? So when we were discussing the epidermis earlier on, I said to you that the outer layer of the epidermis contains these pancake-like cells, these flattened squamous cells that are full of this protein called keratin. So you can therefore understand that hyperkeratinization might mean that you have too much keratin, or more precisely what it actually means is that you have too many of the cells that contain the keratin. So let me explain more what I mean by that. So remember, the epidermis is supposed to shed away and the cells go off into the outer world and we replace them. What happens in hyperkeratinization is that the shedding away doesn't happen perfectly, and instead you end up with the epidermis becoming a bit too thick, i.e. it takes longer for the outer layer of cells to actually shed away. They hold on to the epidermis and take too long to shed away. And of course, the cells at the base of the epidermis are still dividing and producing more cells that are then detaching from the base and coming up and turning into these pancake keratin-filled cells. So you're going to end up with a too thick epidermis, and that causes a problem at the entrance to the hair follicles, at the so-called pores here, and I'm going to write that word down. It causes a problem at the pores, the entrances to the hair follicles, because imagine what happens if this and this become too thick. What will end up happening is that they overgrow and end up blocking the entrance to the hair follicle. So let me draw it in here. So imagine that this has now overgrown and its border is now here, and this is overgrown and its border is now here, and you can see that that's blocked the pore, it's blocked the exit to the hair follicle. This is what hyperkeratinization is and how it's going to cause a problem. So let me summarize again. So the fundamental problem that causes acne is this big word, hyperkeratinization, and this refers to skin cells not shedding away quick enough, not shedding away properly, problems with the shedding away of skin cells, and this phenomenon is not properly understood yet. People are researching why this happens and ways to stop it from happening, but we don't fundamentally completely understand why this happens yet. What we know is that it does happen and that it is the fundamental problem that causes acne. When skin cells do not shed away quick enough, the whole epidermal layer is going to become thicker, and this is going to cause a problem at the entrances to the hair follicles, because of course the entrances to the hair follicles are lined by epidermis, and when that epidermis gets too thick, they're going to end up occluding the entrance to the hair follicle. Okay, so that is what is meant by hyperkeratinization. The epidermis becoming too thick, the keratin layer, which is the layer of these pancake cells full of keratin, becomes too thick. Hyper means too much. Keratinization refers to the keratin layer, the layer of pancake cells full up of keratin. Okay, so it causes the blocking of the hair follicle entrances. What happens next? Well, this is where the sebaceous glands become involved, and the sebaceous glands get blamed so much for the pathogenesis of acne, but actually, they're not the fundamental problem. The fundamental problem is the hyperkeratinization. So the sebaceous glands are, of course, down here, and they are secreting their sebum, and they continue to secrete their sebum. And in fact, unfortunately, in the teenage years, under the influence of androgens, and we'll discuss androgens a bit more later on, under the influence of androgens, the sebaceous glands actually become a little bit more active, so they secrete even more sebum in the teenage years, so this just adds to the problem. But what's going to happen, even if the sebaceous glands weren't secreting more sebum, is that the sebum is going to get stuck in this pore underneath the blockage here. So this is going to become full up of sebum here. And the whole thing is going to blow up like a balloon. I'm not going to draw that because it would ruin the picture, but imagine the whole thing blowing up like a balloon. It swells, basically, because it's getting so full of sebum. Now, we are now ready to discuss one of these types of lesion here. This blocked hair follicle, this blocked pore full up of sebum, this actually becomes so big, it blows up like a balloon and becomes so big that it actually forms a visible spot. This is what closed comedones are. This is what whiteheads are. That little thing there, that is a hair follicle that is blocked up and is now full up of sebum. It's not yet inflamed, we haven't talked about any inflammatory action yet, but it is a little acne lesion, and it represents a pore that is blocked and full up of sebum. So that is the stage that we've got to so far. We have got to the stage of whiteheads. We have explained where whiteheads come from. So that's what I meant when I said earlier on that whiteheads are actually more foundational to the pathogenesis of acne than the inflammatory papules, even though these ones look worse. So, we now want to understand where do the blackheads and where do the inflammatory papules or nodules come from. So, there are two options now of what can happen. This balloon is going to get higher and higher pressure inside, and eventually it's going to burst. The question is, where does it burst? Does it burst open at the top? Does it force this bit that's clogged up here open and then release onto the surface of the skin? Or does it blow up inside the dermis? And depending on which one of those happens, determines whether you get either an inflammatory papule or nodule, or whether you get an open comedone / a blackhead. And at this point, you might like to guess which case refers to which one. So, in the case that the top bursts open, so the pore bursts open and the sebum exits onto the surface of the skin here, all this trapped sebum that's built up in the pore, if that bursts open onto the surface of the skin, that is what happens that leads to a blackhead. And this is why it's called an open comedone, because the comedone refers to the build-up of sebum in the hair follicle here, and when it's closed, it's trapped, the entrance to the pore is clogged, and when it's open, this initial plug has been burst open and the sebum is now coming out. So, when the top bursts open and the sebum comes out, that produces a little black lesion like this, and that is what's known as an open comedone or a blackhead. Alternatively, if it breaks open at the bottom, then all the sebum goes into the dermis here, and I'll try and draw this here. So let's imagine, let's get a dramatic colour, let's get an evil red colour. So if it bursts open here, then all of this sebum will come into the dermis here. And there's another bit that I need to add on here. So we have to introduce another star in the pathogenesis of acne, which is the bacterium Propionibacterium acnes, P. acnes for short, but I will write out its entire name for you. So Propionibacterium acnes. This is a species of bacterium, and this is a commensal on the surface of the skin. Everyone has this on the surface of their skin, and it is not harmful. It lives on the surface of our skin and doesn't cause us any problems. However, it also lives in the hair follicles, and usually it doesn't cause any problems. Again, it's just on the surface. It's not inside your actual body, it's just on the surface. So it doesn't cause any problems when it's there. However, when we're discussing the pathogenesis of acne, when the pore becomes clogged and the hair follicle here becomes full of sebum, producing a comedone, the Propionibacterium acnes bacteria inside here, they have a party. They think this is wonderful. They start dividing and dividing and dividing because sebum is full up of fat. Propionibacterium acnes can use fat to live. So you end up getting absolutely loads of Propionibacterium acnes living, and I'll draw these as little red dots. So here, these are representing the Propionibacterium acnes, and it's completely out of scale, of course. These are tiny, tiny, microscopic little organisms. But these red dots are representing the Propionibacterium acnes population increasing inside our comedone here. Now, that then causes a problem if the comedone bursts into the dermis, because now all of these bacteria have also come with the sebum into the dermis here. And the dermis is the inside of the body. Bacteria are not supposed to be on the inside of the body. That is an infection, and that is going to cause inflammation. The body is going to harness white blood cells and proteins from the bloodstream and move them into the tissue fluid, the interstitial fluid, to fight these bacterial invaders, because we are now under threat, because this bacterium is now not on the surface of the skin, it's actually beyond the surface of the skin inside the dermis. So what you're going to get is a full inflammatory reaction there. You're going to get a red area, you're going to get a hot area, you're going to get a swollen area, and you're potentially even going to get a painful area, the 4 cardinal signs of inflammation. And that is what happens to form these inflammatory papules. So when the comedone bursts down into the dermis rather than bursting up onto the surface, that causes a problem because it then releases this infection, these bacteria that have grown in the sebum into the dermis, and then the body causes an inflammatory reaction to try and eradicate that bacterial infection. And that is the story of the pathogenesis of acne. So let's just recite that again to make sure it's clear. So fundamentally, the thing that goes wrong is this hyperkeratinization. For some reason, the skin doesn't shed off properly, and you end up with the epidermis becoming too thick. This then causes the blocking up of the pores, the blocking up of the entrances to the hair follicles. What then happens is the sebum is blocked from being able to exit the hair follicle. And remember that its usual passage is to exit the hair follicle and go onto the surface of the skin and perform its wonderful role of moisturizing the skin. Instead, it gets blocked down in the hair follicle and the whole thing starts to swell, blowing up like a balloon. This causes the appearance of closed comedones, whiteheads. That is what a whitehead is. This lesion is a blocked pore with sebum building up in the hair follicle beneath it, but it has not yet burst open. Either way, what can now happen to a whitehead is one of two things. It can either do the better thing, which is to break open the plug in the pore here and release its contents, the sebum filled up with the Propionibacterium acnes that has divided and increased its population size in that sebum, onto the surface of the skin, and that just produces a tiny little black lesion here. And the reason it turns black is something to do with oxidization of chemicals. I don't completely understand it, but something happens when the air comes in contact with this sebum that's built up here and with the Propionibacterium acnes, and you get a tiny little black lump there. But you don't fundamentally get inflammation because no Propionibacterium acnes has crossed into the dermis. Alternatively, the plug in the pore can stay closed and the whole thing can burst the other way and burst into the dermis and release all the sebum infected with Propionibacterium acnes into the dermis. That is a problem because that bacterium is not allowed inside the body. So the body will then initiate an inflammatory reaction, as it should do, to any invading bacteria. You'll get dilation of blood vessels, which will cause redness, and you'll start to get proteins and white blood cells that can fight the bacterium and kill the bacteria coming out of the bloodstream and into the area, and this will cause swelling. You'll get loads of inflammatory cytokines released, and this will result in maybe a little bit of pain. Okay, and that is how inflammatory papules, and if the whole thing is big enough, inflammatory nodules form. So, the thing that I now want to go back and talk about is a little bit more about why hyperkeratinization happens and the role of androgens in this. So, androgens are blamed for hyperkeratinization. We're not completely sure. The whole thing is still being researched and it's still a little bit controversial, but at present, we do believe that the fundamental cause of acne is hormonal problems, and androgens are seen as the main culprit, and they are seen as the driver of hyperkeratinization. So androgens are blamed for this. So let me just tell you a little bit more about androgens. So androgens are the male sex steroids. They are steroid hormones. They have the steroid chemical structure. And men have far higher levels than women. In men, the main one is, of course, testosterone, and this is produced by the testes. Women have androgens as well, and the androgens are secreted by the adrenal glands. So in men, the testicles aren't the only things that create androgens. The testicles create the main one, which is testosterone, the archetypal androgen. But there are also the adrenal glands which secrete androgens. They secrete less famous ones, and they also secrete these hormones in women as well, which is where women get androgens. So testosterone is found in high levels in men, and that's secreted by the testes. So I'll put this here. But there is also two less famous androgens that are very important, which are androstenedione, which is the precursor to testosterone. You can convert androstenedione into testosterone with one enzymic reaction. And then also the precursor to androstenedione, which is something called dehydroepiandrosterone, which is a massive great name. Dehydroepiandrosterone, which for short is abbreviated down to DH for dehydro, and then E for epi, and then A for androsterone. Okay, so those are the two androgens that are secreted by the adrenal glands, and as I say, they are secreted in both men and women. But in men, you also have the testicles, which are secreting testosterone. In women, of course, you have the ovaries, which will be secreting the female sex hormones, estrogens and progestogens. Okay, now, all of these, testosterone, androstenedione, and dehydroepiandrosterone, they are all androgens. They all bind to the same androgen receptor and cause the same effect. Testosterone is stronger than these two, but these two can still bind to that receptor and cause the same effect as testosterone. So that's why we group them together as the androgens. So, when you go through puberty, that is when the adrenal glands start to secrete androstenedione and dehydroepiandrosterone in both boys and girls. In boys, when they go through puberty, the testes will also start to produce testosterone, so they'll end up with that additional androgen added on. So the androgen levels go up after puberty, and this is believed to be why you develop acne only after going through puberty, because these androgens are believed to somehow drive the hyperkeratinization process. They are blamed for somehow causing this problem that stops the skin cells shedding correctly and therefore causes the epidermis to overgrow and clog up the pores in this way. In addition, to add insult to injury, to make matters worse, the androgens also increase sebaceous output after puberty. So they work on the sebaceous glands as well and increase the amount of sebum that is being secreted. And that makes the whole thing worse, because now, not only have you got the hyperkeratinization clogging up the hair follicles, but you've now also got increased sebaceous output, so you're going to get the hair follicle blowing up like a balloon quicker than you would have had if the androgens weren't also exerting this effect on the sebaceous glands. So this is how androgens cause acne in these two ways. Fundamentally, remember the hyperkeratinization. They are blamed for hyperkeratinization, which is the fundamental problem. But they also increase sebaceous output. But I want to make this quite clear. If androgens didn't cause hyperkeratinization, if you didn't have the hyperkeratinization and androgens just increased sebaceous output, that would not alone be sufficient to cause acne. That would just make the skin a little bit more greasy. It wouldn't cause acne. You have to have the hyperkeratinization, this blocking up of the pore, to actually get acne. So this is the fundamental part of the pathogenesis of acne rather than the increased sebaceous output. Right, so we have completed the story of the pathogenesis of acne. We'll have a break here, and in the next video we will discuss some of the treatments available for acne.